Recording started.
I would like to welcome everyone to our class this week. We have talked in our face-to-face lecture regarding software architecture. We looked at one example, which is the client-server architecture. We then looked at on how we choose a good architecture for our systems or the system we are designing. Today it's just an extra curriculum or extra things to let you see the different architectures there are. Of course there are more, however these architectures are not required from you in the end of the course. However, just understanding and knowing what the differences are and where they are. So the first architecture we will look at is the main subprogram, which is the most simplest and the oldest way of architecture, where you have the main program runs different functions and different procedures from different modules, and you get from different data. This is the simplest architecture, the easiest to implement, and usually used for small applications. The benefit is its simplicity and bringing all the program together in one place usually. Sometimes when there is complexity, it's really hard to put everything together and you need to separate them. When you separate them, usually you use object-oriented architecture. Object-oriented architecture is separating things into multiple objects and making these objects interact with each other. It helps separating and simplifying the complexity. It breaks down the program in many objects. So when you change things or you want to add functionality, it's easy to know where to place them. You could create a class diagram or an object diagram where you have the class name, the attributes, and the methods. You also could have relationship between them. The disadvantage usually is the use of the memory and use of memory. Sometimes maintainability is hard when you have very complex objects interacting with each other. Sometimes it has a very good testing features, so you could test different objects. Then we go to the layered architecture, which is layers of functionality over functionality. Usually it's used in the operating systems. So when people try to build operating system, they put things in layered one on top of each other. So you have the user application, same let's say Microsoft Word. And this Microsoft Word interacts with the input-output management, such as a keyboard, a mouse, and so on. You have the message interrupter, which interrupt things. Memory management. You have the memory management that manages the RAM, your hard disk, and so on. Then you have the processor scheduling, so it schedules the task within the process. Another architecture is called pipe and filter. Pipe and filter are usually used in parallel systems or in usually systems that interact with different systems. So you have here the filters. The filters contain processes or functions that are used. The pipes are these between the processes, which transfer the data from one place to another. Usually when you use parallel systems such as this, so things work together and work in the same time. And it is very good for complex systems and multi-processing systems. We have the implicit invocation architecture, which is an event-driven architecture, which helps break down things into events. So you have the master control, for example, and the master control creates an event of print results. A print results gets the line, which is a function, and you have different events happening to get all together to run just a simple application. We have then data-centered architecture, where all the application is connected to a database and data-centric, and the software, the client software or the application, will not run without the data store. The data store is centered, so all the application or all the clients connect into one data store. Then we have the service-oriented. Service-oriented is providing services for or providing a platform for clients. For example, if you want to create a mobile application for football, let's say you want to get the FIFA results, all the results around the world. To do so, so you want to create a mobile application for results, and you want to get the results of the, maybe say, the Saudi league. To do so, what you try to find is to find a service broker for the FIFA. And with the FIFA, you register to this service. Within the service, you could request data back and forth. And these services have different functionality that you could use within that client. Okay? So this is one of the most used architecture in web technologies and mobile applications. It's a very good architecture. It helps separate the functionality, the service functionality, and the client functionality without any problems. It's a very scalable architecture, and it's easy to test and easy to maintain, maintaining the service alone and maintaining the client. Last but not least, as we've seen in our face-to-face class, we looked at the client-server architecture, where you have a client interact with the server, and that server brings information back and forth or has functionality. You could connect the server, the client and the server through the internet or any kind of connection. This is some references that you could go and see regarding the different kind of architectures. Any questions? Okay, so regarding the quiz will include all topics after the midterm until now. Also, assignment 4 is now available. The deadline is on the 12th of December, so in 10 days. Okay. Any questions? Quiz will be next week, so make sure that you come next week for the quiz. It will only take 5 minutes. Sorry, maximum of 15 minutes. I will combine the marks of the first quiz and the second quiz, inshallah, and put them before your exam, inshallah. Any questions? Okay, that's it for this week. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.